Hey everybody, this is Larry. This is me doing day 5. Yeah, day 5 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, come have a chat. Today's problem is House Robber 3. We did the other, was it House Robber 2 maybe? We did another one a couple of days ago, so let's see. The deep reserve found the only one way called root, okay. Okay. So I mean, I think the way that I would think about this, in general, is that, um, a, yeah, just recursively, but try to look at my video or watch the video from a couple of days ago. We go over the logic there, and since we did it recursively, I think that would have a very a very intuitive sense as to the way that we'll solve this, because you can think about the way that I think about it is that for a problem like this, first, you have a tree, right? But first, think about it if you have an array, right? So we have an array, so then now we think about if we have a linked list, right? Because a linked list is kind of like a tree in a way, is a degenerated form of a tree. So definitely think about it that way. And then once you kind of, now you have the array or linked list version, which, you can convert from an array to a linked list very easily. Then now think about that recursion and then think about how that applies to a tree. In this case, yeah, we'll see how that goes, and we'll just do it recursively. Let's see. We might need to do a memorization, and there are a couple ways to memorize, but we'll get to that problem when we get there. So we just kind of, the way that I would think about it is just thinking about asking myself the question that I want to know for each node, right? And here we go. So then now we have go house of node, say. Now this is a recursive function. We're going to call it with the root maybe, but we'll see if that's true. So if node is none, then we just return 0, right? Let's see. So then maybe here now I'm just thinking through of, well, if you do the array implementation, you have this idea of being able to skip ahead. And here in theory, you can be able to skip ahead, and then you do like, I don't know, node.left or node.left right or something like that. But maybe something that we can think about in a more precise way is just whether the previous was used, right? And this is like parent used maybe, because you're only going down from the root. So yeah. So then here now we go, okay, now with these recursive problems, just try to be as maybe brute force as you can. Maybe that's the way that I would go about thinking about it. In that, just enumerate all the cases as much as you can, so that it encompasses every case that you can, right? So okay, so if the parent is not used, and sometimes there's overlap, but let future use figure that out, right? Let's just break it down, even if there's input cases, or not input cases, but even if there are enumeration cases or whatever, like even if you break it down and there's some overlaps, worry about that later. Anyway, if the parent is not used, that means that we can use this node, right? So that means, that using this node is going to give us, we could go to the, what does that mean? That means that after we use the node, we go to node.left, parent is used because we used it, or go.house node.right, and also true. And of course we take the max of these two, right? Because that's recursive. We take the max of these two, either we go left or we go, wait, let me see. Oh, okay, actually, sorry, I didn't know if you could, I don't know if you're going one path or you can go the entire, okay, so actually I was wrong about this one, because you can go to them independently. Of course you just go both, so recursively you do this, right? So actually I was thinking about like a one path situation, but in this case you are able to go both, so you would go both if you're allowed to. So this is the current score. Plus, using this house, of course, it's going to give you no.value or no.val, right? So yeah. So let's just say this is best, and this is if we want to use this house. Okay, maybe just score using house, right? And then we do another one. We go if we do not want to use this house. Then in this case, we just go, score not using house. Then we just skip this house.left, parent is not used, plus go.house of no.right, false, parent is not used. And of course, we don't add the no.right because we're not using the house. And then here we can just return the answer of max of either score using house or score not using house. That's pretty much it for the parent not used. And then now the other case, obviously, is that if the parent is used, then what do we do? Well, there's no score using house because the parent is used. If the parent is used, you cannot use this house, so we don't even do this. In this case, then we do get that we cannot use this house, and when we don't use this house, then we just have this thing, right? So we can just actually, copy and paste, and then just return this here. I think this would be good enough. And then now we start off with the root of go house. Let's just say so there are two cases, right? From the root, the beginning case. So you could go from the root where no, actually I think that's okay. So false because there's no root doesn't contain a parent, so we can do false, and that should be good enough. There may be some, so yeah, there's some memorization here. Is that true? Yeah, there's some memorization that we can use here, but let's just kind of run it to see if we get anything reasonable. If this is wrong, obviously we'll just, we need to fix it before we even think about memorization. So yeah, so this looks good, but of course we're doing duplicate things. I'm too lazy to really print out. Maybe I can get still a big note because there are a lot of notes here. I don't know if I'm gonna just make this a full tree so that it's easier to kind of do what I'm doing, which is spam this input out. See if this gives me a time limit exceeded. I actually don't know if this gives me a time limit exceeded. Ideally, we'll have a okay. Ideally, we have whatchamacallit. We have a linked list, but this is actually a tree, so it's actually maybe more like we're actually creating log n of this, but this is not the worst case because there could be, the worst case is a linked list where, okay, so this is too many nodes. So this is not the worst case, right? Because if you don't cache, probably the worst case is n squared, and given that n is 10 to the 4th, it may be yucky, maybe even exponential, but in any case, so maybe I cannot construct but I am going to bound the, so okay, so maybe it's, you can see that this is 400 milliseconds, so let's think about that in terms of, okay, can we improve of it? Yeah, and we're going, because this is probably going to be either n squared or even exponential in a way. Not going to go over the complexity that much, but because we're going to add memorization. So let's add a memorization. There are a couple of ways you can do this. I'm going to do this in a very naive way and hope that this is fast enough. If not, we'll play around different ways. To be honest, this is not the way that I would do it during a contest, but this is just an illustration. So we just have a cache lookup is equal to a dictionary, and then here we go if we put in a tuple. If this is in cache, then we just return the cache containing this tuple, and otherwise we cache it and then return it. So here we do, and here we also cache this, right? So we recorded that before. I think it took 400 milliseconds, 470 milliseconds. So let's see if this is much faster. So this is 65, so we're already immediately faster. though there is some caveats about how to do this, but there's immediately faster. So let's go over the complexity real quick now that we memorized. Notice that node can be one of any nodes, which means that this can be up to 10 to the fourth. So it's O of n, where n is the number of nodes, right? And is any nodes in the list. Of course, parent used can be true, false. So that means this is 2. This means that the number of possible inputs is O of n times 2, which is O of n, of course. And of course, each call will take O of 1 time. So each input takes O of 1 time. So this is going to be O of n total time. And yeah, and each input takes O of 1 space because, that's the number of entry in cache. So O of n total space. That's all I have for this one. But before that, let me submit. Apparently, I've done it twice before, so hopefully I do a little bit better. Okay, so I did, I do reasonably. Let's look at. I'm curious what I did last time. But I should have a video for it, I suppose. Yeah. So actually, it seems like I did mostly. That time I did break it up into 2 cases. That's fine. So this is actually another way of doing it. It's kind of similar to how we do the stock thing, where so we did it in 2 different ways. Let me make this smaller. Let me know what you think about these 2 techniques. So you do have questions about this solution, which I'm not going to go over that deeply. Please watch that solution, because actually I like that solution as well. I like this solution rather. So I probably like that video and how I explained it. So go check that out. But that's all I have for tonight. Day 5 done. One that's like 20% or something, 16%, something like that. That's all I have. Stay good, stay healthy, to good mental health. Have a great rest of the weekend. I'll see you later. Bye bye.